Bismillahirrahmanirrahim. Yesterday we have talked about the research philosophies and how do we actually try to understand research philosophies so that we understand what kind of research we are doing. We have talked about ontology, epistemology, etiology, axiology, and number of other terms that we think might make sense to understand at this level of research methodology, so that we know actually how research and knowledge actually generated with the passage of time. When people try to start doing research on one or the other issue, how research is actually generated, how knowledge is actually accumulated, and how it becomes a separate field or add to an existing field of knowledge. So we have talked about positivism, we have talked about realism, we have talked about direct and critical realism, and then in detail we have talked about induction and deduction. We have seen that deduction is basically a process we normally do when we conduct our research, because normally we start from theory and we end up rejecting or accepting the hypothesis that we have developed. That is what we do in deductive reasoning. While in inductive reasoning, we start with data that is available with us. We start trying to see how the data behaves, what kind of issues we try to see with the data, how that data helps us to answer one or the other question, and based on our analysis and interpretation of the results, we'll be in a good position to see what kind of theoretical linkages we can found, or maybe we can be in a position to develop a relatively better way or new theory in that particular field of knowledge. How this process moves on, how it helps us, we try also to see the similarities and dissimilarities between induction and deduction type of research approaches. We compare and contrast both these things, and then in the end we also try to see the 8 hallmarks of research. If I just give you a glimpse of not all the 8s, because we have already discussed in our previous lecture, but some of the important things of research were the design of research, its generalizability, and how do we design is basically important, so as we can look at what kind of data we need. And when we know what kind of data we need, we will be in a position to decide what kind of sampling or what kind of sampling technique we are going to use. That is, we are going to discuss today understanding sampling, what are the sampling techniques, how do they exist, how do we use them, what are the benefits of that. But one thing that I want you to understand or learn from this is that how linked these steps are. So we started from a simple topic and research question, we moved on to critical literature, then we saw how research design, what is a research design, what it needs, how it is designed, what are the research strategies that we can or may use, what are the advantages of using this or that way of research strategy, and then we saw what are the research philosophies that can help us understand what kind of research we are conducting. And now we are talking about, after learning how to develop theoretical framework and hypothesis, we will, in today's lecture, will talk about understanding sampling. What is it, how we conduct it, what is its importance, and why we have to do sampling to understand the whole population. So one other characteristics of 8 hallmarks of research was generalizability. Why do we sample population? Why can't we do the whole survey of the population or the survey of whole population, so that we can be in a position to say something with surety? There are a number of reasons for it. One obvious reason is that we are in a position not to conduct the full census rather than survey, because we are limited. Number 1, we don't have much time. Number 2, we don't have much resources. Number 3, we don't have much human resources to conduct a country or nationwide census. That's why Normally at national level we have census around after a decade, 10 years. In Pakistan we have this haphazard kind of thing, but last time we had in 1998, before that we had in 1981, and normally if it is the case, it has to be after every 10 years. So first was in 1951, so according to that it must be 1961, 71, 81, 91, 2001 and 2011, but due to political instability, one or the other policy reasons, we were unable to conduct our population census timely. So what we had now is that the last one was in 1998. It was supposed to be in 2008, but due to shift from one political regime to another political regime, democracy came in and we were unable to act on population census. And since then, in the last 5 years, we are unable to have any census. The other thing that we have to keep in mind that even these 8 hallmarks of research are linked to how you take your various steps to conduct your research, to answer the question that you have asked in your research topic, or to seek your objectives of research. I told you that one was design, that is important to understand, and the other was generalizability. Why I'm talking about these two? Because they are two directly linked to the topic of today and the next lecture, because we are talking about sampling in at least 2 lectures, and we'll see if there is something remaining we'll talk about in our further lectures also. So understanding sampling, I told you, is important for various reasons. One is that it's difficult for us to conduct a nationwide or a population-wide survey, so we have to take a representative sample so that we can understand the characteristics of population. For example, if we want to see rural poverty in Pakistan, we cannot do a survey at all rural areas in Pakistan. So what we do, we basically, using one or the other techniques of sampling, we get a representative sample. A representative sample is also an important aspect that we have to understand, that how we can say that that sample is a representative sample. We'll try to see how we use various techniques, how we understand the way sampling and survey is conducted, and what are the difficulties in selecting this or that kind of techniques, how techniques help us to understand in a better way the characteristics of population. The basic idea behind sampling is that we have to choose out of population a representative sample or units that actually help us to generalize our results and interpretation for the whole population. So for example, if we see that poverty in rural areas is among those people who are having a relationship with agriculture, but those who are having non-agriculture activities along with agriculture activities are less poor. So what we do, we basically start looking at 2 kind of people. One who only have agriculture, others those who have agriculture plus non-agriculture activities. And then we try to compare how do these 2 groups of people behave. Before understanding what kind of data we need, we have to understand how do we sample them. What sampling technique we will use to see how many of representative sampling units we need from, let's say, those who are related to agriculture only, and how many sampling units we need from those who are related to agriculture and non-farm activities. These are some of the important points that we have to understand for sampling, because if we don't know why we need sampling, we will be unable to answer why are we doing sampling. So we have to understand the importance of sampling first. So why to do sampling? So that's what we try to answer. And before we go into details, first we have to distinguish between census and sampling. Sampling is relatively less cumbersome compared to census. Census normally is done for some things or some units of analysis at 100% level. So census is basically at population level. So if we want to see how many tractors we have in Pakistan, we start counting each and every tractor that is in the field in agriculture or any other in the whole country, not only in rural or urban areas but in urban slums, in any area of Pakistan. So that's called census. Sampling is when we want to see what kind of tractors are working in Pakistan in rural and urban areas. So we take few rural areas out of total rural areas of Pakistan, and we see few urban areas out of total urban areas of Pakistan, and then we start looking at whether our data can be generalized or not. Same is the case with poverty. When we measure poverty at rural or urban level or at national level, what we do, we take sample from rural and urban areas, and based on one or the other measure, we estimate poverty at rural area, at urban area, and then we measure at national level, and then we project at national level that, and we understand that in Pakistan poverty is, let's say, around 27% or 19%, or it is increasing or decreasing with the passage of time. So census has some characteristics that it's absolutely representative. We can generalize anything when we talk about census because it covers the whole population. But the only thing that is difficult about census is that you need more financial resources, you need more time, you need more human resources, and it is very much time consuming. Because if you want to count how many people live in today's Pakistan, you need number of months actually to count it. Once you start counting from every household, you have to take care of their ages, you have to take care of their gender, you have to take care of their other characteristics, and whether they are in a school or not, if they are not in school, why they are not in a school, and all these characteristics that helps you understand how and why population behaves in this or that way. That's why when you want to do a simple research for a research paper, a research project, or a research dissertation, you, instead of doing census, do sampling, which is convenience because entire population survey might be impracticable. So if you want to have even time and money and human resources, it's very difficult for a single person to reach out every single household within a country to conduct a census. Even at a village or a district level, it is difficult because when you reach a house and want to ask some information, they might object why you are asking something that is very personal to them. Why do you want to know how many household members they have? Unless you have a government letter or a letter of an authority that gives you an authenticity. So keeping these things in mind, a researcher must look for sampling rather than census. A census is a very big idea, a very big thing to conduct. Hence, sampling is valid or preferred over census because entire population survey might be impracticable or might not match to the objectives of your research, because you have an objective, you have a research question that you want to answer. So census might not be suitable for you to answer the question. I mean, it's not that you cannot answer it, but it might not be needed at all. So why to waste resources, financial, time, human resources on just that issue? So instead of census, you go for sampling. Budget and time constraint restrict data collection. So you have budget or time constraint. So if you have to complete your dissertation in 6 to 12 months, it's difficult for you to conduct census. So what you do, you go for any sampling survey where you can collect data in, let's say, 2.5, 3 months, so that you have ample time to understand your data, to enter the data, to clean it, analyze it, interpret it, so that you can finish your research in a timely manner. This is one thing. Secondly, that should also have a match with your research objectives and research question. And if that is the case, what you basically come up with is within given time period you will be in a position to complete your research. Not only given time period, but within the available scarce resources that you have. And need results from data collection quickly. Let's say you want to have a quick analysis of something. Quick does not mean that you need it in an hour or so. Quick means that you might need it in a month or two. Or for your dissertation needs, you might need in 6 months. So Census might not be in a position to answer your thing in, let's say, 3 to 4, 6 months. So what you do, you basically do sampling survey so that you can be in a position to answer as quickly as you can because of the time constraint. So this is how you distinguish between census and sampling. And that is why sampling is preferred when you do individual level or even group level research for a specified objective and a simple research question that you are interested to answer in your research. So now we'll be talking about how do we do sample selection. In a very simple plain word, if you see this circular or Venn diagram kind of stuff, where you have seen blue stars tells you about the whole population. So suppose this is the whole population that you want to do survey on, and you want to select a sample out of it, and each single star actually is a case or an element of the population or an individual within a population. So you take a representative individual, a set of case or set of element, and you call it a sample that is in a separate small circle which tells you that out of population you have chosen few stars that represents your sample. So this picture is taken from the book Zonder et al. That I have already recommended you. So what do we understand is that instead of covering the whole population, asking them question or whatever, what you do, you basically select sort of elements within a population and you call it your sample. What kind of techniques you used, why you use that techniques, and why it is important to use this or that technique to have your sample is very important to understand. Number one, why? Because your sample must be representative. Number two, your results can be generalizable. Number three, your sample must represent the whole population characteristics, if not truly, at least on average basis. So these are important things you have to consider when you do or when you use various sampling techniques. So we'll see later in today's lecture that we have sampling techniques of probability and non-probability. In today's lecture we'll discuss about probability sampling, how it is conducted, what are various ways of conducting probability sampling and all. But at this level, the only thing that we have to understand is that it might be difficult for a researcher in a limited budget and time frame to conduct survey of each and every case or element. So what one can do as a researcher is to select a sample out of that population so that the research objectives that he has for his or her research or a research question that he asked in his research paper or dissertation can be answered easily. So that's how we basically select sample out of population. What is sampling frame? We have to understand this term carefully, that sampling frame for any probability sample is a complete list of all the cases in the population from which your sample will be drawn. So in our previous example, sampling frame is basically the whole yellow star, the yellow circle that we have. So sampling frame, we have discussed that it is basically a complete list of all the cases in the population from where the sample is drawn. So for example, in our previous slide, this whole yellow circle or somewhat circle is basically the total population that we have, and that's where we have to select our sample. So in this case, this whole circle where I marked with red is basically our sampling frame. Let's look the definition once again. The sampling frame for any probability sample, the complete list of cases or elements. We have seen that this blue stars, for example this or that, is basically a case or an element. So sampling frame in any probability sample is a complete list of all cases or elements in the population. So this is the complete list of all the cases or elements within the population from which your sample will be drawn. If we are selecting a sample from this whole list, so this is actually our sampling frame, and from that sampling frame what we have chosen is this as our sample. So from population we have chosen cases or elements, and that becomes our sample. So the whole population is known as our sampling frame. Identification of sampling frame. How do you identify that this is the whole population, and then based on that you will select your sample. So key points while identifying sampling frame are problems of using existing databases. You might fall in a problem of using existing databases. So if you use existing databases, you will be in a position to either fall in a trap that you will not cover up the whole population and extent of possible generalization from the sample, and it also have to have a possibility that the generalized statement can be said from the whole for the whole population from the sample. It should be valid and reliable, and it must not be biased. So for example, if we just go back to our this picture, so what we can actually say about this is that we want to survey those people who have job in, let's say, a firm at managerial level. So this is the whole population of people who are working in various organizations at managerial level. So you want to access them all, but you want to generalize your research analysis for every managerial level person within the population. So your sample should be representative. It must not be that you choose these two versus these two versus these two because they might be close to where you are working or where you are living, or they might be close to each other because you went there to interview, let's say, these two people. So you have decided that let's go to those who are close to them. Rather than doing this, it's better to select your sample which must be representative so that you can have valid results, you can have reliable results, and you can be in a position to avoid bias. Whenever you try to do sampling or whenever you are doing sampling, this bias is one of the important thing that one has to avoid. This research bias, personal bias, data bias actually do two things. Number one, your results are not interpretable, or even if you can interpret them, it's not that robust. Even if you can get some results, they cannot be generalizable because of the bias in your data or the bias in your sampling frame when you want to collect data from a population. So these things actually harm you when you try to do a biased sample survey. So avoid bias, start not using the existing databases. You must know that your results can be generalizable from the sample, so it should be representative. Your results must be valid and reliable so that one can understand that the sample is true representative or nearly true representative of the population, that you can say any argument or a statement for the whole population also. Sample size, that's also another important stuff. The choice of sample size is influenced by the four important factors. There can be number of other issues, but these are the four important. Confidence needed in data. How much confidence you can be about your data depends on the sample size. Margin of error that can be tolerated. What kind of error or how much error you can tolerate. Normally in a statistical analysis, if you see voting behavior or one or the other human or consumer behavior, you always see written plus minus 2, plus minus 3, plus minus 1.5, plus minus 2.5, something like that. So plus minus 2.5 means that the margin of error is between the total result might be less 2.5 or above or plus 2.5. So it will be added or deleted from that. So if you add or delete these two, it actually tells you that much is the margin of error. Types of analysis to be undertaken, what kind of analysis you are doing, and size of the sample population and distribution. What is the size of sample population and how it is distributed. So these four things are very important to understand. So first thing that we have to understand about our sample is confidence on the data. How much confidence we have on our data. Second is the margin of error that we can tolerate. How much error we can have. Error does not mean that your sampling frame or the data that you have collected is wrong, but error means that it's not close to the total population's average characteristics, or how far it is from total population's average characteristics. So for example, you say that majority of the people in rural areas of Pakistan are poor because of this or that reason. So on an average, everybody does not have that particular reason to be fall in poverty, but majority of them have the reason or that particular reason to fall in that poverty. So that's where your margin of error plays an important role. How tolerable it is for others to understand and read. So that's where the margin of error are important when you select your sample size. Then you have to understand also that what kind of analyses you are doing. What kind of analysis your research is requiring. If it is a simple descriptive analysis, or if it is a modeling where you need various variables so that you can prove your results to be stronger, robust and conclusive, so that you can conclude something out of it. And what is the size and distribution of population that you want to sample. How it is distributed and what is the size of total population. So if the total population is, let's say, 50,000, then how much will be the distribution of your sample? But what if it is 500 million? So that basically tells you that how much out of total population you need to make your sample a representative of your research or for your research. So this is how you basically do sample selection or sample size selection. Response rate and its importance. So we have to understand that response rate is also important. Response rate is basically when you select sample out of population, you want to survey these population, you have prepared a questionnaire, you want to collect data from that. Either you go and personally interview them, or you send data through electronic mails or emails or whatever, and then you see how many of the respondents are actually responded. Let's say you have selected 300 people, and out of 300 people actually 200 are responding and 100 is not responding. So the response rate is actually 2/3. Instead of all 100%, it's around 67% people who have responded, or 66.6% people who have responded. Rest has not responded. So response rate is important, because we have to consider that non-respondent analysis of refusal, why people did not respond, why they refused, obtaining a representative sample, because we have already selected a representative sample. So if it is 66 to 67%, or let's say 70% response, does our sample still remain a representative sample or not? And if we say that our sample still remains a representative sample, then we can go ahead, or else we have to think whether we have to collect more data, or we have to do resampling, or whatever techniques we have to use, so that we can make our sample or the responses more representative of the whole population, calculating the active response rate. So we have to understand how much is the active response rate of the sample population that we have actually used to collect survey or questionnaire. Estimating response rate and sample size. Then we have to estimate what is the response rate, what was the sample size. How much was the sample size relative to population, how much is the response rate relative to sample size and relative to population, and then we will be in a position to see whether it is representative or not. And representation is important because of the three very valid reasons. Number one, we have already talked about, is generalizability. Number two, we have already talked about, is validity of your interpretation and results and analysis. And number three is reliability, whether they are valid or not, whether they are reliable or not, and they can be generalized at population level or not. And if you can answer to these three questions positively, then definitely your sample is representative. And now we'll talk about sampling technique. So here we'll just simply see that what kind of sampling techniques we have and how we actually understand them. So first we have to understand that we have two broader categories of sampling. So first is probability, that is our first sampling technique. The other is non-probability, that is our second sampling technique. So probability and non-probability sampling, and then we divide probability and non-probability sampling into various categories. We will discuss each and every segment of probability and non-probability sampling, and also probability and non-probability sampling as such in detail a little later, but first we have to understand what comes where and why. So we know that under probability sampling we have simple random sampling, we have systematic, stratified random, cluster, and then multi-stage. Multi-stage is basically a combination of all the previous four, that is simple, systematic, then random, stratified random, then cluster, and we combine these four into multi-stage sampling. Probability sampling or simple random sampling is basically where you have equal chance or probability to come under. But non-probability sampling is not necessarily that you have similar chance or same probability of being sampled. So under non-probability sampling we have quota sampling, number one, we have snowball sampling, we have convenience sampling, that is normally used at master's level dissertation by various students, self-selection, purposive sampling, and we have extreme case, we have heterogeneous sampling, we have homogeneous sampling, we have critical case, and we have typical case. We'll try to see the most important from non-probability, for example, quota, purposive, snowball, convenience, self-selection, but we will not go into much of the details of extreme case, typical case, critical case, because they are normally done in medical or other kind of natural sciences, but not normally in social sciences. So, or let's say business or managerial studies. So most of the focus normally remains on probability sampling, and within probability sampling definitely on stratified, cluster, systematic or simple random sampling. Very few use multi-stage sampling. Within non-probability sampling, majority of the people go for either snowball or quota sampling. Students at undergraduate or graduate level, when they write their dissertation, it's difficult for them to have a sample size which is true representative of population. So what they do, they go for convenience sampling, where they choose their sample size according to how much they can actually survey, rather than the true representation. But that convenience sampling is also based on something close to what a sample can say about the whole population. Not that much reliable or that much generalizable, but at least close to what we can say about the whole population. Purposive and self-selection is also used, not that much, especially by the students who are writing dissertation, but that is also used in various researches. And this is how sampling is distributed. In simple words, sampling is distributed in probability and non-probability. And within probability, we have 5 techniques, that is simple random, systematic, stratified random, cluster, and then multi-stage. And while in non-probability sampling, we have quota, snowball, convenience, purposive, self-selection, extreme case, heterogeneous sampling, homogeneous sampling, critical case, and typical case. So this graphical representation of sample techniques is also taken from Zonder et al.'s book, which we are referred for this course, and you can also see in the sampling chapter this graph is located. Although in the slides you can also get, but simply we have to understand that probability sampling is the sampling which is normally used by various international and national organizations to collect a relatively large sample for a bigger studies. And non-probability sampling, or within non-probability sampling, especially convenience sampling, is used by the students for their undergrad or graduate level studies or dissertation. You can also use probability sampling if you're collecting your own data, but definitely you have to have then various tools and techniques to understand what kind of sampling techniques you are using within probability sampling, why, and then whether this represents your whole population, and whether your results can be reliable, valid, and generalizable or not. So you have to understand these 3 points, important points, very keenly. What is probability sampling? We have to understand that with probability samples, the chance or probability of each case, you remember we have the whole population. Within population we have sample, and for each unit within a population we called it a case or an element. So within probability sampling, the chance or probability of each element or case being selected from the population is known and usually equal to all the cases. So for example, we have a class of 30 students, and if we want to select a sample based on probability sampling from the class, then every single student has a chance to select for that particular sample within the class, and that chance is equal to 1 by 30. So out of 30, every single person has a chance of 1 by 30. That is how we understand probability sampling. So it is the sample or it is the probability or chance of each case or element being selected from the population usually equal to all the cases. This means that it is possible to answer research questions and to achieve objectives that require you to estimate statistically the characteristics of the population from the sample. So that is one of the most representative way of selecting sample from the population which is true or close to true representative of the whole population. So this helps us, or this makes us possible from our sample selection through probability sampling, that our results are close to generalizable or close to the average of the whole population. Consequently, probability sampling is often associated with survey and experimental research strategies. So either you do survey or you do experimental research strategy, they are close to probability sampling. I'll not go into the detail of survey or experimental research strategies because during our formulation of research design, we have already talked about the key features of research, experimental and survey research. I hope you remember. So we will just understand that probability sampling can be associated with either survey or experimental research, because survey or experimental research you do on sample, but that sample must be true representative of the whole population. That's what we need from the probability sampling also. Probability sampling is a 4-stage process, as it is mentioned here, that first we have to identify, then we have to decide, then we have to select, and then we have to see the representation. So first thing is that we have to identify the sampling frame from research objectives. Sampling frame, identification of sampling frame from our research objectives. What is our research objective? When we know clearly our research objective, now you understand the importance of clarity of your research objectives. When you have a clear-cut objectives of your research based on your research topic and research question where you want to do research, then you will be in a position to actually identify your sampling frame. And sampling frame, we have just read or learned that sampling frame is basically the population within which or from which we want to select our sample or case or element. So if you are clear about your objectives of research, then you will be in a better position to identify your sampling frame. Objective and sampling frame selection are closely linked, so that you have to see that the stepwise process of writing a research, how they are closely linked together. We have decided about our objectives in the very beginning, first steps of our research, but when we are planning to collect data, for example, for our research, we have to understand and go again to our research objectives, where we can see how the objectives are linked to the sampling frame selection. Then we have to decide about the suitable sample size. We have already talked about that sample size selection is also very important because of the reasons that sample size help us understand data, number one. Number two, it helps us interpret data and generalize the interpretation of our results. Validity and reliability also depends on sample size, the suitability of sample size. After identifying sampling frame, we have to talk about sample size, and we have to decide about sample size. Then we have to talk about appropriate technique selection. And of course, when we talk about appropriate techniques, we have seen probability, non-probability. Within probability, we have 5 simple clusters, stratified and multi-stage, this kind of, and then within non-probability we have quota, we have convenience, we have heterogeneous, homogeneous, extreme case, typical case, these kind of things. So once we talk about appropriate technique, then we'll definitely see whether probability or non-probability, and within probability whether we go for this or that, or within non-probability we'll go for this or that. and then after that we have to talk about sample. We have to talk about sample, that what kind of sample we are going to collect and how we have answered all the 2 questions, and then we check whether the sample is representative or not. Representativeness of sample is also very important. Rule of thumb normally said in statistical studies, while you want to have a representative sample, simply speaking that it must be close to or equal to 5% of the total population. But in various cases, when you want to conduct a survey, let's say you want to conduct a survey of youth and their use of, let's say, social media, for example Facebook or Twitter or any other thing. So social media, let's say you have a strong use or a strong exception of youth using social media within Pakistan. So 5% of that youth will be a huge number of population sample size. So if you identify that use of social media within province of Punjab, that still is very high. Within the twin cities of Punjab, Rawalpindi and Islamabad, still it's very high. So either you go for convenience sampling or you discuss about those who are studying in government universities within twin cities. So then you will be in a position to see whether you're talking about Arid Agriculture University or Quaid-e-Azam University or some other government university from where you can take sample. Even still taking 5% of the total sample is relatively difficult because of the constraints that you're facing on your budget or time or human resources. So what you can do, you basically go for non-probability kind of sampling where you try to use convenience sampling. So these are the 4 processes or stages that we have to understand before deciding about probability sampling. Identifying sampling frame, that will be coming from research objectives. Deciding on suitable sample size, then selecting the appropriate technique and the sample, and then checking the representation or representativeness of the sample that we have selected. Selecting a sampling technique out of what we have, that is 5 techniques used under probability sampling: simple random, systematic, stratified, cluster, multi-stage. So these are the 5 sampling techniques we have that we can use to select our sample size and representative sample size. What is simple random? It's basically selecting at random frame using either random number tables or computer or an online random number generator such as research randomizer. Randomly selecting frame for sample size. In Excel you have random number generator also. So once you decide your sampling frame or random frame, then you will see how random you can be to choose one or the other sample or case or element. And this is how we start doing simple random sampling. Systematic sampling. So how do we do systematic sampling? Systematic sampling involves you selecting the sample at regular intervals from the sampling frame. Simple random, we don't follow any regular or any interval. We'll just do everything randomly. Every case or element within the sampling framework or population is selected absolutely randomly. But within systematic, what you do, you basically generate or you give, so for example, first stage is number of each case in your sampling frame with a unique number. So you give numbers to your case or element within population. You start, let's say, from 0, then second can be given as 1, third can be given as 2, 3, 4, and then so on. Let's say you have 300. So you start from 0 to 300. You give each element or case as a unique number and then select the first case using a random number. So what you do, you basically use first number as a random number and then you have to calculate the sample fraction, and then every, let's say, third, every 7th, every 5th you select, and that's how it is different from simple random and it becomes systematic random sampling or systematic sampling. So what we do basically, systematic sampling, it involves selecting the sample at regular intervals from the sample frame. So it's a regular interval selection every third. So 0, 1, second is selected, 3, 4, fifth is selected, 6, 7, eighth is selected. So every third is selected, or whatever you decide at random. So number of each case in your sampling frame with a unique number. Let's say number you start from 0, then 1, then 2, and so on. Select the first case using a random number. You use a random number to select first case, and then you just go on and select your sample. Calculate the sample fraction. Select subsequent cases systematically using the sample fraction to determine the frequency of selection. So when you selected 1 using the simple random number generation, then you calculate the fraction so that you can see at what distance or at what difference you have to select the other sample, and then so on. And this is how you basically move with systematic sampling. Then you have stratified random sampling. We had simple random sampling, then we had stratified random sampling. So stratified random sampling is basically where you make strata of your population. So looking at stratified random sampling is a modification of random sampling in which you divide the population into a more relevant and significant strata based in on a number of attributes. Let's say in a class you have a strata of gender, male, female. This can be one strata, or maybe you have a line of CGPA less than 3.3, more than 3.3. In effect, your sampling frame is divided into number of subset. A random sample, simple or systematic, is then run from each of the strata. So within stratified random sampling, what you do, you basically divide your population into stratas, and within strata you either use simple random sampling, that you do random number generation and you select randomly whatever you have from one strata, and also simple random sampling within other strata. So from two subsets you select randomly, or you do it systematically. So you divide your population into strata, and then you try to give them unique number within these two stratas, and within these two stratas, when you give them unique number, you again do the same, that you try to get one random selection. Based on that you calculate fraction, and based on that fraction you go sequence wise to select your sample out of that two stratas that you have identified. So this is how stratified random sampling is combination of basically simple or systematic random sampling, but the only difference that we do is basically we divide into stratas. We divide population into stratas. And stratified sampling shares many of the advantages and disadvantages of simple random or systematic sampling. So then we have cluster sampling. Instead of doing stratified, you do clustering. You cluster them together: poor, middle class, rich, rural, urban, working in sugar factory, working in textile mill, working in let's say ghee factories. So you cluster them. Similar to stratified, as you need to divide the population into discrete groups prior to sampling. So you group them together. Professors who hold PhD from let's say abroad, professors who hold PhD within Pakistan. So the groups are termed as clusters in this form of sampling and can be based in any naturally occurring grouping. For example, you could group your data by type of manufacturing firm or geographical area. People coming from rural areas of Punjab, one group. People coming from urban areas of Punjab, another cluster. And based on cluster you do your sampling. For cluster sampling, your sampling frame is the complete list of clusters rather than complete list of individual cases within population. So you cluster them, you group them separately, and information of each and every group is basically important rather than individuals' characteristics. So for cluster sampling, your sampling frame is the complete list of clusters. That is important rather than the complete list of individual cases or elements within population. Select a few clusters, normally using simple random sampling. So out of various clusters, use simple random sampling to choose 1, 2, 3 of whatever number of clusters you want to choose. And out of that clusters, you will be in a position to collect data from every case within the selected cluster. So it can also be time consuming because cluster can be of big size, and for each cluster it will not be possible for you to collect data for everyone. That's why it is used by a relatively bigger organization for a bigger research study. Multi-stage sampling. It is a development of cluster sampling. It is normally used to overcome problems associated with a geographically dispersed population when face-to-face contact is needed, or where it is expensive and time-consuming to construct a sampling frame for a large geographical area. So we do multi-stage sampling. However, like cluster sampling, you can use it for any discrete groups, including those that are not geographically based. Technique involves taking a series of cluster samples, each involving some form of random sampling. It's very simple that you basically form a simple random sampling technique, and based on clusters you do multi-stage sampling. So you divide population into cluster. Within cluster you use one or the other way of collecting your representative sample. This is how you basically use multi-stage sampling. So today we actually talked about sampling, its importance, and various ways of sampling techniques. Before we finish today's lecture, I just want to remind you some important points that we have discussed in today's lecture. We have discussed where do we do sampling, where do we do census, and how do we use sampling and where. Why census is important, why sampling is important, where your objectives are small, where your objectives are limited, where your objectives are too few, and you need a simple data to verify your objectives or hypothesis, you go for sampling. But when you want to know at national level what is happening with, let's say, the population growth, with literacy, with poverty, then you definitely need a census for that. Census has some disadvantages over sampling, but definitely census is more representative or true representative of population. Sampling can show the averages, it can be close to the true representative of population. And then we discussed about how to select what is sampling frame, how to select sample size, what is the response rate and its importance, how do we need to know sampling response rate, why it is important, and these simple concepts so that we understand what is sampling. And that's why we called our today's lecture Understanding Sampling. Then we used to come to know about the techniques of sampling, that is probability sampling versus non-probability sampling. And within probability sampling we have 5 techniques, that is simple random, stratified random, systematic, cluster, and multi-stage. And we try to see what are they, how they are conducted, what are their importance, what are their advantages and disadvantages, and why do we do these kind of sampling techniques. And within non-probability sampling we saw that we have quota, we have snowballing, we have convenient sampling, we have heterogeneous, homogeneous sampling, we have extreme case, we have typical case, and we have some other kind of sampling that you can see from the graph. And within today's lecture we also discuss about the 5 approaches that we use, or the 5 techniques we use under probability sampling. within probability sampling, we discussed that the probability of selection of each case or element is equal to the total number of that particular group. For example, I have given you an example of if a class is of 30 students, then every person or every student's selection chance is equal to 1 by 30th. So that's how we do probability sampling. And within probability sampling, we have talked about random sampling or simple random sampling, where we saw that you select your sample based on simple random selection, and that can be used through randomized researcher or using Excel random generating numbers. So you just generate some random numbers, and then based on that you select one or the other population or sample group. Then we saw systematic. Within systematic, we saw a little difference from typical simple random sampling is that you number them uniquely, your sample starting maybe from 0, and then using simple random sampling technique, you use one random number based on which you calculate fraction, and then that fraction is used to select your further sample. And because we number the sample or case or element within a sample, and then we use simple random technique, we called it systematic, because we move systematically, because we give them a unique number. Then we discussed about cluster sampling, stratified random sampling, and multi-stage random sampling. Stratified random sampling, we have talked about that we stratify our population or sample into various stratas, and then we use either simple random or systematic sampling frame. Then in cluster, we have decided that we make various clusters out of our population. Based on that, we select randomly few clusters, and then we use again simple or stratified random sampling to collect our data. And multi-stage sampling, we have discussed that it's basically combination of cluster and stratified random sampling, where we use one or the other way of collecting data, either clustering or stratified random sampling, or combination of that, and we called it multi-stage. And within that, we use either simple random or systematic random sampling. That's why in the graph you have seen that it's a combination of all the other 4 techniques of probability sampling. So this is how we do sample. And we also talked about the importance of why do we do sampling and why do we need to do sampling, because of the 3 important reasons. Number 1, that our analysis and data should be representative, valid. Number 2, the interpretation of our results is reliable. Number 3, our results can be generalizable to whole population or to the population we are concerned with. So these are the important aspects of sampling and understanding the sampling techniques. So today we end here, and inshallah in the next lecture we will talk about non-probability sampling techniques, how do we conduct, and then we will try to compare how non-probability techniques are related to probability techniques, what are their differences, where we can go for, let's say, non-probability techniques and why, and in what circumstances we can use probability techniques and how. And this will help us to understand, especially for those who try to analyze primary data or want to collect primary data for their research, this kind of sampling techniques will help, or what kind of sampling technique can help them selecting their representative sample size based on their objectives, and how to avoid researchers' bias when they select a sample. And that will definitely help you to select a more valid, reliable sample which is a true representative or close to true representative of population, and based on that sample the results that you got can be generalizable to the whole population. I stop here and thank you very much.